Greeting learners. So we're going to continue with our session. Remember, last time we finished with exercise number 4, and under exercise number 4 we have taken 4. Now here is exercise 5 under exercise number 4. Consider the sequence 1/4, 3/16, 5/64, 7/256. 5.1 state the next two terms in the sequence, and 5.2 determine the end stem of the sequence. Solutions. 5.1. So if we can watch very well our sequence, we can see that we have got 4 first terms. They say state the next two terms. So the next two terms are going to be, term number 5 will be 9 over, and the denominator will be 4. Then we get here 1024, and the next one will be 11 over 4 to the power 6. We get 4096. So these are the next two terms. We're going to explain this in question 5.2. 5.2, determine the end stem of the sequence. As you can see here, the numerators form an arithmetic sequence with the first term being 1 and the constant, the common ratio, the common difference is 2. The first term is 1 and the common difference is 2. If we want to get Tn, for the numerators, we'll be having Tn is equal to A plus n minus 1 times D. Tn will be equal, the first term is 1 plus n minus 1, and the common difference is 2. Tn will be equal to 1 plus 2n minus 2, and Tn will be equal to 2n minus 1. This is for the numerators. As you can see, if n is 1, we'll be having 1. If n is 2, we're going to get 4 minus 1 is 3. If n is 3, it will be 6 minus 1, and then we're going to get 5. So for the denominators now, here we're having denominators. As you can see, the denominators is the power of 4. So we're having here 4 to the power of n. If n is 1, we're getting 4. If n is 2, we're going to get 16. If n is 3, we're going to get 64. If n is 4, we're getting 256. That's why the next term here is a 4 to the power of 5, 4 to the power of 6. So our Tn here for this sequence will be equal to, the numerator will be 2n minus 1, and the denominator will be the powers of 4. So we have here the general term of the sequence is 2n minus 1, and at the denominator it will be 4 to the power of n. This is the answer of question 5.2. So the end stem of this sequence is 2n minus 1 over 4 to the power of n. So we're practically done with this first part of the sequence of the exercises number 4. We're going to go to the next unit now, as we have covered This was unit 2. I'm going to clean the board and then we will continue with unit 3. Unit 3 is going to be the sum of arithmetic series. Unit 3. The sum of arithmetic series. So an arithmetic series is formed when the terms in an arithmetic sequences are added together. So here's an example. I'm going to say an arithmetic series is formed when the terms in an arithmetic sequence are added together. So as I'm going to consider these first numbers, 1, 2, 3, dot, dot, the last one will be 10. This is an arithmetic sequence. Now if I consider 1 plus 2 plus 3 plus dot dot plus 10, this is going to be an arithmetic series. Arithmetic series. As you can see the difference, we're talking about an arithmetic sequence which we have got terms of an arithmetic sequence. If we get the sum of these terms, we're now having what we call an arithmetic series. Now, let's consider the series. Consider the series 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. We're going to work out the position of the last term. Let's work out the position of the last term. If we want to get the position of the last term in this arithmetic series, we can see this. Our first term, let's consider that the nth term is going to be 10. The first term is 1, and the common difference is also going to be 1. So A will be equal to D is equal to 1. We want to work out the position of the last term. So we will have here Tn is equal to A plus n minus 1 times D. Our last term of the series is 10. So we'll be having 10 is equal to 1 plus n minus 1 times D. the common difference being equal to 1. So we will get here 10 is equal to 1 plus n minus 1. 10 will be equal to 1 plus n minus 1, and our n will be equal to 10. So this is the position of the last term is n is equal to 10. I've considered a simple example of the first 10 numbers from 1 to 10. So we're going to see with this series how to get the sum of an arithmetic series with this first example. I'm going to clean the board so that we can have enough space. Okay. As our arithmetic series will be written like this. S10 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. I'm going to consider the very same series, but now I will start from the last term. We'll be having that S10 will be equal to 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Today we're having, this is the first series. The second, I'm going to take here 1 plus 2. 1 plus 2, it means we're adding these two series. Then we'll get 2 times S10. It will be equal to 1 plus 10, we get 11. 2 plus 9, we're going to get 11. 3 plus 8, we're getting 11. 4 plus 7, we're also getting 11. 5 plus 6, 11. And here 6 plus 5, 11. 7 plus 4, 11. 8 plus 3, 11. 9 plus 2, 11. And 10 plus 1, 11. As you can see here, we're having 10 terms. Let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2s10 will be equal to 11 multiplied by 10 because we're having 10 terms. So finally, if we want to get our S10, it will be equal to 11 times 10 divided by 2. Using a calculator, so 10 divided by 2, we're getting 5. And 5 times 11, our S10 will be equal to 55. So now, we're going to consider the general case where we'll be having an arithmetic sequence from T1 to Tn, how we're going to get the sum of an arithmetic series in general. So I'm going to clean the board to have space. The algebraic proof below applies to all arithmetic series and is examinable. Required to prove Sn is equal to n over 2 multiplied by 2a plus n minus 1 times d. So we're going through the proof now. A is the first term. D is the common difference. I'm going to write it like this. And n is the number of terms with L being the last term and L is equal to A plus N minus 1 times D. We're going to prove this. If I'm going to consider, as I've done it previously with the first 10 numbers, here we're having the arithmetic sequence starting from T1 to Tn being the last. And the first term is A, the last term is L, A plus N minus 1 times D. As I've done it previously with the first term terms, I'm going to do it now with A being the first term and L being the last term. So this is what we're going to have. Let me clean and have some space here. So Sn will be equal to A if I consider A to be the first term, and we'll be having A plus D, A plus 2B plus dot dot, and then here I'm going to have L minus 2D plus L minus D plus L. This is the first series. I'm going to consider the very same series. Now I'll start with the last term. Then I'll be having L plus L minus D plus L minus 2D plus dot dot plus here I'll be having A plus 2D plus A plus D, and the first term is A. Then we're having the same series repeated but reversed. So now let's get the sum of these two. As we have done it previously, we're going to take 1 plus 2, and then we're going to get 2. Sn will be equal to A plus L. If we consider the next one, you can see here we'll be having A plus D plus L minus D. D minus D is going to be cancelled. We'll remain with A plus L. We'll be having A plus L. For the next one, this is going to give us 0. We'll remain with A plus L dot dot. Here the same, we'll be having minus 2D plus 2D. We're getting 0. So we'll have A plus L. The next one, minus D plus D is 0. We'll have A plus L. And the last one will be A plus L. As you can see here, on the right hand side, we'll be having N times A plus L terms. So we're going to have here 2 Sn is equal to N multiplied by A plus L. And finally, our Sn will be equal to N over 2 times A plus L. Now, as it was required to prove, we must get that Sn is equal to N over 2 times 2A plus N minus 1 times D. Remember, we're having L is equal to A plus N minus D times D. We're going to replace here L by A plus N minus 1 times D. So this will imply that the Sn will be equal to N over 2. And here L will be replaced by this formula. And then we're going to get 2A plus N minus 1 times D. We have covered the proof. So here's what it was required to prove. We got that Sn is equal to N over 2 times 2A plus N minus 1 times D. So I'm going to clean the board, and then we will continue with some remark on this particular sum. So before you decide which version of the formula to use, you must check the information you are given. So as you can see here, if the information given is the sum, then we can come to this conclusion. Remember, Sn is equal to T1 plus T2 plus T3 dot dot plus Tn minus 1 plus Tn. If now I consider Sn minus 1, it will be equal to T1 plus T2 plus T3 plus dot dot plus Tn minus 1, as you can see. And from these two arithmetic series, we can get a new formula, and that formula will be Tn will be equal, as you can see, if I consider this Sn minus 1, we're only going to remain only with the Tn. So Tn will be equal to Sn minus Sn minus 1. It's so easy to understand. I'm taking the first arithmetic series minus the second one. We're only going to get 0, 0, 0 here. We're only going to remain with Tn. So Tn will be equal to Sn minus 1. So with this formula, it's going to be easy to get Tn according to the information you'll be given in the question. So in some question, you may need to use both. It means the general term, Tn, and the sum in order for you to respond to the question. So I'm going to clean the board now and take some worked example so that we can understand very well the use of this formula. We're taking a worked example now. Here's the worked example. Sn is equal to 2n squared plus 9n. First question, determine the first 3 terms of the sequence. 2. Determine the 12th term by using the formula Sn, meaning Sn is equal to 2n squared plus 9n. And the third question is determine the 12th term by using the formula for the nth term. Solutions. Number 1. Determine the first 3 terms of the sequence, meaning T1, T2, and T3. So we're going to use this formula. We'll start by saying S1 will be equal to 2 times 1 squared plus 9 times 1 is going to be equal to 2 plus 9. Then we get 11. So P1 will be equal to 11. Remember, S1 is equal to T1. We're going to take S2. S2 will be equal to 2 squared plus 9 times 2. And this will give us 2 squared is 4. 4 times 2 is 8. 8 plus 18. And this is going to give us 26. 8 plus 18 is 26. Then we're going to go to S3. S3 will be 2 times 3 squared plus 9 times 3. Then we'll have 2 times 3 squared is 9 times 2 is 18 plus 27. 18 plus 27. Then we're getting 45. So it's 45. Now we're having already our Tn because S1 is equal to T1 and that is 11. Now let's get T2. T2 will be equal to S2 minus S1. We know the value of S2 is 26 and S1 is 11. 26 minus 11, then we're getting 15. And after we're going to go to T3, T3 will be equal to S3 minus S2. So it will be 45 minus 26. 45 minus 26 must be 19. Let's just check. 45 minus 26, we get 19. So here is our T10. T1 is 11 and T2 is 15 and T3 is equal to 19. This was the first question. Determine the first three terms of the sequence. Here are our first three terms. Now we're going to go to question number 2. I'm going to clean the board so that we can have some space for question number 2. We're going to question number 2 now. Here is our first three terms for the first question. Question number 2, they say, determine the 12 terms by using the formula Sn. So we're going to say here, S11 will be equal to 2 times 11 squared plus 9 times 11. Then we're going to take the calculator. 2 times 11 squared plus 99. Then we're getting 341. And S12 will be equal to 2 times 12 squared plus 9 times 12 is going to be equal to, we're also going to use a calculator, 2 12 squared plus 9 times 12. And then we get 396. So now our T12 will be equal to S12 minus S11, and then will be 396 minus 341. As you can see here, we're going to get 5918. So our T12 will be 55. That is the answer for the second question. Determine the 12th term by using the formula Sn. And question number 3 was getting this T12 by using the formula of the general term. So here we know by considering this our first three terms that the first term is 11, and if we want to get the common difference, it will be 15 minus 11, we're getting 4, and 19 minus 15, we're going to get 4. So our common difference D is equal to 4. So to get T12 is going to be, let me remind the formula is Tn, A plus n minus 1 times D. So here our n is 12, our A is 11. It's going to be 11 plus 12 minus 1, and the common difference is 4. T12 will be equal to, let's use the calculator, 11 plus 11 times 4, and then we get 55. As we can see, here is 11 plus 44, then we're getting 55. As you can see, for the second question, using the formula, the sum, we got T12 is equal to 55, and use